So let's talk about lexical this. This is one of the most important lessons you should learn about JavaScript. It's relatively complex to grasp, so please pay attention because this is very important. And of course, sooner or later, it's not only that you'll get these questions on a job interview, it's that every single company will ask you about that. Right? So if you don't learn that, it's because you don't want, because this is super predictable. They are going to ask you about this. Right, so I would like to present you an example. So I'm going to create an object, evaluation, and this object will have some properties, right, about our evaluation. So for instance, the score, right? So this evaluation, someone got a score of 71, so good for him or for her. And then we're going to create a function called getScore of the name, and that will return the score for name is, sorry, that's a function, yep, score for name is score, right? So then we can call evaluation.getScore of Albert. So if we do that, the score for Albert, wait a minute, yes, so this is not what I want to do. I want to do this dot score exactly, right? So we got 71. Let's play it again. Yep. So the score for Albert is 71. Why 71? Because we are doing this dot score. So score is a property on the evaluation object. That makes sense, right? That makes sense. But then now, what happened if I transform that into an arrow function? This will not work. That sounds brave, but let's see what happens. The score is 22. 22. Why 22? It's very weird, right? You'll never expect 22. What is 22? I never typed 22, right? So, in other words,
it's a window.
It's a window, exactly. That's it. It's hidden, but it's somewhere. So somehow before the start of the session, I type something like that. You see? Doing this is quite obvious. You got the window object, right? But this is the same and doing that. Implicitly, if you initialize a variable without declaring it, without using let, var, or const, the variable will belong to the window object. So if we do that, you see?
Can you write this into there?
Yeah, I'm not going to write this, but I'm going to add a breakpoint. So let's try again. Right, you see, this points to the window. Why this points to the window, but if we change it back to a classic function, this points to the evaluation object?
Because this is called by the function, and that function is on the object.
Yep, that's correct. So in this particular example, which is classic JavaScript, this refers to the object that invoke the function where we are inspecting this, right? So this points to evaluation. Do we have evaluation.score? Yes, printed, right? However, when we use a when we use an arrow function, the situation changes. Because by using an arrow function, this is not, so JavaScript is not changing the scope. In other words, the scope, this will point to the parent. So the parent is the global context, which is window. So by doing that, this will refer to the window object. And then it will say, do we have the score property on the window object? Do we have it? Yes or no?
Yes.
Yes. And what happens if I delete it? Do we still have it? Do we still have score on the window object,
It's undefined.
it's undefined. It's not undefined because I haven't changed the window somehow. That's why we shouldn't do that. That's why it's so risky to create globals like that. If you do that, this will be persisted globally, right? Everyone will have access. Don't do that.
So if you look now in the score window, we can see the score is equal to 43.
Exactly. Let's add a breakpoint. So if I do window, I get lots of things, right? Whatever. But if I do window.score, it prints 43 because we've declared it here, right? That's why this, it will say, okay, which is the closest function? Is this a function? Is this a classic function? It's not? Okay, keep investigating, go to the top, go to the top. Wait, there is no function. So if there are no functions, I'll take window as my reference, right?
Why can't it recognize that it's not a function?
Sorry?
Why can't it recognize it?
Because that's one of the goals of arrow functions. So arrow functions, from a scoping point of view, are not considered a function,
Okay.
right? So if you write,
If you put it into another function, classic function.
Yeah, well, that's
I'll go back to this example. Yes, I'll go back to I'll do that. I'll do that in a minute because I'm going to talk about classes, which is about nesting functions. I'll do that in a minute. But again, remember, for now, in this particular example, it will ask, okay, this, which is the closest function, is here. Okay, then, so this will point to the object that called that function. Which object called the function? Evaluation. Okay, let's do it. Right?
it sounds like it's always good practice to always put like the name function.
The name function.
Yeah,
Why the
right
name function?
As opposed to always using arrow function.
Well, it depends. So if we want to do that, if we have an object like that, my suggestion is use a classic function, because in this particular case, it looks obvious that the purpose of the developer was to access that property, not the window one, right? So you have an object and you want to do this kind of OOP, object-oriented programming, then it's safer to use a classic function.
How about how do you like return, like, because you sent me some, like when I sent you the question, you said try doing it without return.
Without return.
Yeah, like returning, like let's say if you're using like reduce or something like that. I don't know if you can.
No, but that's completely unrelated.
Oh, okay.
Yeah, that's something else. That's about how to do inline return with arrow function. But we can do that actually, Tamani. If you want, we can do that. Look. So if you have a classic function, you need to use a return statement. But how can we avoid using the return statement here?
Just
Get rid of return and the bracket.
Get rid of return
and the condition.
and the curly brackets. Correct. Look, Tamani. So if we do that, right, we are making it inline.
It's valid only if you have only one argument. If you have two arguments, name and something else, it won't.
So according to Christian, this won't work, right?
I think that will work. No, if there's one, you can take the actual
Correct.
brackets in.
Correct. You can have as many arguments as you want. The only difference is if you just have one argument, you can simplify a bit.
Okay.
Exactly. You can get rid of the parentheses. I have to say that I'm not a big fan, and this is just a personal opinion about this syntax. And the reason is, if I see that, because we read the code usually from top to bottom, right? And then I will ask myself, okay, what is this object doing? Evaluation. I got the score, which is a property, and then I got a value. And then I got new get a score, which is the value is a variable. I say, I don't know, wait a minute. It's a function, right? So the first time I read that, I will read something like that. And then I need to keep reading to realize this is a function. However, if I do that, I know this is silly, But that definitely helps me to realize quicker that the value of get a score is actually a function. Again, styling, right? And also, if I add a new argument, it's much easier, right? Otherwise, you need to change the shape and you need to add the parentheses when you need them. Okay? Any question? No? Right, so that was the first thing I wanted to talk about, but still, there are more things about the this object. So I'm going to transform the example a bit. In this particular case, and let me recap, we agreed that using a classic function is more convenient, because then if you use a classic function, you can access the properties of the object where this function belongs to, right? So that's okay. But then let's talk about classes. Can you tell me how to create an evaluation class? You should know how to create classes already. Class, evaluation, that's it, right? Let's keep it easy, right? I don't want to extend anything. So I'm going to create a function called getScore. This is like, when React, you do these kind of things, right? The only difference with React, you create few callback functions like component mount, render, constructor, etc., right? But in this particular case, I want to keep it simple. So I want to have I'm going to add a constructor, and as part of the constructor, I'm going to create a variable score equals 54, right? So I'm going to make it slightly more complicated. So let's assume that getScore calls the backend, right? Because we need to check on the database, whatever. So we want to make this method asynchronous. How would you do it? How would you return something asynchronously? Callback or promise. Let's use a promise, right? Sounds more elegant. So I'm going. How do you return a promise? You tell me. Return new promise resolve, and then whatever you want to do inside, right? So because this is going to call the backend, I'm going to simulate some delay. So I'm going to add a timeout. You remember timeouts? And this will take a second, for example. Oops. Right? So how do we resolve a promise? How do we tell that this promise is over? Then what? No. I want to finish that. I want to do something here to tell, hey, this is okay. Return what? No. We don't need to return anything, right? Why we're passing a resolve argument here? What's that? Yeah? So what do we do with the argument? How do we resolve that? Second? Dot find?
No, where you need to get it from.
Right. I'm not following you guys. So, and I think you are not following me either. So I'm going to do let evaluation equals new evaluation, right? So, and then the only thing I want to do is I want to do evaluation dot get score, right? And then I want to do dot then I got the score, so console.log the score is, right, and let's use the template literals. So the score is score, right? So what will happen if I run the example? Will this console log ever run? Yes? No? Why? No? Why not, Justin?
It's not within the reference to the score that's in the constructor.
No.
Score is in the function.
Ignore the score variable. So that function is never finished. So then will never run. This function is never completed. Why is never completed?
There's no output.
I hear nothing.
There's no return.
There is no return. Well, there is a return. It's returning your promise, but when you return a promise, you need to either resolve it or reject it.
Yeah.
You need to complete it, right?
So if you're doing this, I was
Resolve and reject.
I don't want to react. I want to resolve it. That's why I'm passing an argument. I want to solve the console log. So you'll tell me how to display a console log. Alright, so that means that no one has watched the video about promises, right?
We need to resolve.
You need to resolve. How do you resolve?
Just type in resolve.
Just type resolve. Okay, cool. Resolve.
Dot.
Right, resolve. And what else? Parentheses. And what else? I want to see the score. What? Yeah, the score, but how do we pass the score? This is not the score, right? Exactly. So if we run that, look, pop, you see, it takes a second, pop, and it displays the score, right? Which is a good thing, because we managed to solve a problem of asynchronicity. But then, what happened if now I change the set timeout function from an arrow function, you got it here, to a classic function? What will this display?
43.
43. Let's have a look. Correct. Christian is right. Why 43?
Because it will take the global variable, because this is it's an arrow function, so it's not really a function, so it's
Yep.
not resting on that object.
Yep.
That way.
Yep. Pretty much. So when the summary here, the functional way to explain that is if you're using a class, because class has this object by definition, it's one of the things that defines a class, you usually speaking don't want to create any classic function like that, because as soon as you do that, you're pretty much lost. You won't have access to this object that is declared by the class, right? It will point somewhere else. Because of that, and just to keep it simple, I don't want to go into too many technical details. Again, if you are declaring a class and you are creating classes continuously because you are creating lots of stateful React components, which are classes, try to avoid using classic functions. Use arrow functions instead. Any question? Right? No questions means that no one understood that. That's what I'm assuming, right?
Where did 43 come from again?
Well, yeah, 43, that's a good question. It's because on the previous example,
Okay.
we did score equals 99. So if we run the example, and with a function, a classic function again, you see? Because we're creating, we're defining a classic function. As we define a classic function, lexical this changes, so it will look at the parent context, which there is no parent context, so it will search on the window object.
Oh, so so the previously deleted
Mhm.
it would just bring that result in
Yep.
because this one's invalid. Okay.
Yep.
So if you ever did want to do it to be classic, you would always have to set like the score, whatever, up the top first to make sure they work.
Well, I mean, that's up to the logic of your components. So in that particular case, we know that our class has a property called score. We know that. That in your particular case, you may have a state, right? Sometimes you want to access the state, set properties, change properties, but that's the same thing. It's something that is declared as part of the this object. So whenever you want to declare something as part of the this object, and then you want to access it, if you are using a class, please make sure that you don't have any callback function defined as a classic function, because otherwise you are lost. So,
Does that
Yeah.
does that work in the same way as when we put class name?
Class name.
Yeah, like when we're on. No, it's not a class, is it?
Yep.
I'm a bit confused because about 10 minutes ago you said when you use
Yep.
classic function,
Yep.
and this will refer to
Yep. The object
object
that call that function.
object that call that.
Yeah, which is true in that case. Why? Look, if I add a breakpoint here, now, look, this is important. That's a good question, Albert. Right, look at the breakpoint. This should point to the window object. Exactly. Why? We said that when you use this, in this particular case, it will point to the object that called the function, this one, where the lexical this is. So why this is window and not anything else in this case? In other words, this to be window means that that function, the one that I'm highlighting at the moment, is invoked by the window object. Why? Because this is how JavaScript works. So what is setTimeout? setTimeout is a global function. So in reality, maybe you didn't notice yet, but doing setTimeout is the same as doing window.setTimeout.
Oh, and that's why this is.
Yes, now it doesn't want to return anything. So maybe Chrome is, yeah, so Chrome is frozen again, but I'll shut it down because I want this.
Would that still work because you've got a classic function and not an arrow function?
Yeah, but that should return something, right? Even if that should return 99, right? For that case, it should return 99, but it's returning nothing. And this is usually because, you know, Chrome sometimes, see, it's not returning anything. So let me just say that, shut down Chrome, and then open Chrome again. Yeah, that's a very bad thing of Chrome, but you know. So yeah. I'll show you in a second. Right. So this is what we got before. Let's run it to ensure it returns something. You see, now it works. Why 54? Because this is part of the class. If I change it to a classic function, it should be, so what the score will be now? 99, exactly. Correct. And the reason is because when we call setTimeout function, is internally setTimeout belongs to the window object. The same that score in reality belongs to window.score, setTimeout belongs to windows.setTimeout. So if we run it again, see? So the window object invokes the setTimeout function, and then once we got the timeout, the window object invokes the callback function. That's why this points to the window. I never said that was easy. What I said is this is important. So that means you need to go back again and playing with this kind of exercises.
Is there a host of functions like setTimeout
Yep.
that work in the same way that are hosted to the window?
Yeah, definitely. There are several functions that work similarly. Another one will be setInterval. You know what setInterval does?
To run sporadically.
Yeah. So that line will be called every second. So there are a few functions in JavaScript that are globals, right? And that's the way you work with them, right? So usually in daily basis you don't do that. That would look awkward to me. But in reality, this is what's happening under the scene, behind the scenes, right? Yep.
I can understand this part now.
Yep.
But in the very beginning, you said arrow function from
Yep.
the scope's point of view
Yep.
is not considered as a function. So that's
Correct.
What it logs the variable in the global scope.
No. Wait.
Does that happen?
Yeah. So if it's an arrow function, that means that lexically speaking, this is not considered a function. And then it will say, okay, then look on the parent context. So this is not a specific context, but what's the parent context? It's the class itself. So when you declare a class, lexically speaking, is the same as creating a function. So it will create a new lexical this object. So that's why when you do that, the closest scope is not the window, it's the class. Any question?
But it's still inside setTimeout function.
Yep. But
Why doesn't C setTimeout and
Because it's not a function. Set timeout doesn't take a real function.
yeah, correct. So setTimeout is not considered a function. The callback of the setTimeout is not considered a function lexically speaking.
So the argument is not a function.
Well, the argument, it's an arrow function, but lexically speaking, it's not considered a function, right? So technically speaking, it's not changing the behavior of the this object. In other words, this here is the same than this there. However, if you create a classic function, this here is not the same than this there. That's it, right? So where is, in this particular case, where is this pointing to? Window. Thank you. Where is this pointing to?
54.
The class, exactly, right? And again, arrow function. Where is this pointing to? Correct. And where is this pointing to? The class again, right? It hasn't changed. That's the thing. Not sure if you've noticed, there was a subtle thingy on Chrome. No, sorry, ignore me. There was nothing in Chrome. Yes, in my mind. Cool. Is there any question about this? No? Chris? Maybe that question might be interesting for anyone else?
I was just thinking about
Okay, cool. I want to show something else because this will, again, talking about this, and probably to make it even more confusing, but this is like the third part I wanted to describe today. So I'm going back to objects, and this is something that was partially covered by Christian yesterday somehow about memory addresses and stuff like that. So I'm going to show another example. So again, I'm going to create evaluation equals this is an object, right? So score. So I'm going to create two evaluations. Evaluation 1, score 19, and then get score. It's a function. So in this particular case, so this is going to return this dot score. So remember, when we have an object, should we use classic functions or arrow functions? Classic. Thank you. That's what we explained at the beginning, right? So, hey, that's correct, right? And the way to prove this is correct is if we do evaluation 1 dot get score 19. It's all easy, right? We've learned that 25 minutes ago. But then let's create another evaluation. So evaluation 1 and then evaluation 2, and the score is going to be 89, right? So if we run evaluation.getScore, it returns 89. That's easy, right? That's quite easy. Let's add an argument. So I'm going to add the name. Same thing I did before. So it's going to be the score for name is this.getScore here and then there. So if we run this again, if I pass an argument, so I'm going to pass Vicky. So the score for Vicky is 89, right? Nothing exciting. Obviously with evaluation 1, it still works. Cool. But I'm going to make it slightly more complicated. Look at what I'm going to do. I'm going to say, hey, evaluation 2 is the same as evaluation 1 in terms of structure. The only thing that will change is the score, right? Because the scores will be different. But the function, look, this is literally a copy-paste of that. So, I want to save some space on the screen. So I'm going to remove it, and then I'm going to do evaluation2.getScore equals evaluation1.getScore. You got the idea, right? So I'm creating a function dynamically pointing to this one. So now the question is, if I run evaluation 2.getScore, so the question is, and think about that, will the score of Vicky be 19 or will be 89, and why? 19. Everyone 19? Right, so you are all wrong, right? It's not 19, it's 89. Why? Because of the same principle that we learned. This points to the object that called the function, so that's the object that called the function, right? So this points to evaluation 2. So what's the score on evaluation 2? 89, exactly. It's kind of magic, but makes sense, right? This points to the object that calls the function. Which object called the function? Was evaluation 1? No, was evaluation 2. That's why this points to 89. However, if we change it to evaluation 1, it's 19. Because this points to evaluation 1 object. 19. Does it make sense? Yeah. So now, and we are finishing, what happened if we do that? We know this is wrong up front, because evaluation is, if in that particular case, I want to show that Vicky got a score 19. So is there a way we can overwrite this object? Exactly, that's a good thing, Christian. We can bind it. We can overwrite this. We can tell, hey, JavaScript, please, no. Don't point to the object that called the function where this is. Point somewhere else. How can we do that? Look, because this is going to be quite sexy. So instead of invoking the function, we can do .call. Like we're going to call the function, and then as the first argument, we can pass what this object will be now. Exactly. So if we do that, we're going to call getScore, which is here, but this won't be the object that called the function, won't be evaluation 2, it will be evaluation 1, right? So if we do that, you can see that now score is 19, because we've overwritten.
But now if you want to change it, you cannot change it.
If you want to change it, you cannot change it.
If you want this object to point to something else. So now let's say I don't want to point to evaluation 1, I want to point to something else.
Well, but you need to call the function again, right? So you will have to call the function again, like that, right? I mean, you call in the function once. Every time you call the function, this will remain the same until the end of the function. You cannot change this in the middle of the function, right? Does it make sense?
Yeah.
Okay, cool. So in that particular case, you see how we can overwrite the default behavior for the lexical this object. But then you'll see, hey, but wait a minute, user is undefined, right? So how can we pass Vicky to this method here? With literals, yes. You can pass then a comma-separated list of arguments. So if I type Vicky here, you see, it happens. We could even pass multiple arguments. Like I'm going to email, right? So the score for name with email, so I can make an email, right? I can make it up. So I can do foo@bar.com. So if we do that, you see, so we can pass a comma-separated list of arguments when we invoke call. So when we invoke call, first argument is the new scope, and then all the next arguments will be provided to the function. Make sense? There is an alternative to call, and they will ask you this question, and if you don't learn that, you'll remember me in 2-3 years' time when they ask you the question and you won't answer it, is what's the difference between call and apply? because they're very similar, right? So the difference between call and apply, even though they are very, very, very similar, is we learned that call receives a comma-separated list of arguments, but apply receives an array. It's the same thing. Look. So apply has two arguments. First, the new lexical this, and then an array with the arguments, right? So if we run that, still works. There is something classic in my professional life. When I've been asking that question, some senior developers, they said, yeah, I know, call apply, one is a comma-separated list and the other one is an array, but I don't remember which one is it, right? Don't say that, that's bullshit. You should learn what's the difference between call and apply. And it's easy to bring some mnemotechnics. Everyone has a different technique because we don't do that on a daily basis, so it's easy to forget. But the way I remember that forever is apply starts with A and A for array, right? That's it, so simple. So apply receives an array and call is the other one, right? Comma, exactly. Call, comma. Yes, that's good, right? You see? Call is a comma. Separate the list of arguments, right?
What one's best to use?
What's best to use? Well, it depends. It depends on the scenario. It depends on how do you receive the arguments.
Oh.
If you got these arguments from an array, then do that, right? I mean, I find apply more flexible because it's an array. We know how to play with arrays. We know how to sort, how to filter, how to map. We know all these things, right? However, the other one, which is a comma-separated list, right? It will be okay if we know how many arguments that function has. But if we have a list of arguments, we may need to use the spread operator or things like that, right? Which will be still valid, but again, keep it simple. So apply.
When you have the array, then can you in the argument
Yeah. So correct. So technically speaking, we have one argument here, which is an array of two arguments. So this is going to be spread into two separate arguments in here. Yeah, but this is happening under the scenes. You don't have to use rest operator at all here. Any question? Right? Remember, last thing, the first argument of call and apply is the new this. So technically speaking, we can type whatever we want here, right? We can cheat a bit. So the score is 120, right? You see, it works. So it's just an object. So you can provide whatever object you want because that object will be referred by the lexical this.
So you can say that this is binding to.
Yes.
So
This is
something. This to something that you want.
Yeah, absolutely. Yes, you can do that if you want. Yes, they will ask you that. They will ask you what lexical this is, and you will tell, yeah, it's an object that points to that refers to the object that called the function where this shows up. And then we'll ask you next question, how can you override this object? And you will say, you can use either call and apply and pass it as a first argument. Right? Any question? No? So Constantine is smiling because the thing is,
Well, I think I'll forget.
you think we will forget, okay, but then again, as usual, my suggestion is watch the video, don't do like the promises one, yeah, got maybe 3 pieces on YouTube, so I know that no one has watched it, right? So watch it and repeat it, and you know, it's a bunch of 3 or 4 rules, right? It's not that complicated. It's strange, but it's not complicated.
Can we do 2 minutes of constructor function? So.
Yes, but let me say that.